All right, ladies and gentlemen. So we just got done doing basics on inequalities and one-step inequalities. Just adding, just subtracting, just multiplying, just dividing, only one-step inequalities. Now, if we think back to our Chapter 2 test, there's a lot of different ways, there's a lot of different combinations of things that we could do with equations where we have variables on both sides and getting rid of the little guy and doing all that stuff. Simplifying before you start evaluating. That's what we're going to do today. We're going to combine all of those things that we had learned in Chapter 2 now with what we've learned in Chapter 3. Okay? So solving two-step and multi-step inequalities. So let's remind ourselves that inequalities that contain more than one operation require more than one step to solve. We use the inverse operations that we learned in Chapter 2 and apply them to what we know in Chapter 3. Let's solve and graph. 45 plus 2b is greater than 61. Okay, so what operation do I do first? What do I do first to solve this inequality? Subtract the what? Good. Let's subtract 45 from both sides. We subtract 45 from both sides. And that's going to get us 2b is greater than 16. And then what finishes it off? David? Good. So that gives me b is greater than 8. Now remember, you guys have a number line there. You can fill it in. But if this is on your homework assignment, all I need to see is 0 and 8. I see an open circle at 8. Why is it open? Because it's not or equal to. And then going to the right. Questions on that? What does that mean again? That arrow means that any value to the right of 8, bigger than 8, would be a solution. Somebody give me a value that's bigger than 8. John? 9. Not very good. 9. If I plug in 9, 45 plus 2 times 9. Well, 2 times 9 is 18. 45 plus 18 gives me 63. Is 63 bigger than 61? Yes. So it's a true statement in the end when you solve. Okay. Questions about that? So you can always plug back in just like we could with equations. Let's keep it going. Let's keep making it a little bit more difficult here. What's the first step here? What do I do here? What do I need to do first? Good. I'm really glad that you did not say add 8, because that is still an issue. This is not add 8. This is subtract 8. I need to subtract 8. Why are people adding 8? Well, because people are seeing that the minus sign is right there. But it's a positive 8, so I need to subtract 8 over to the other side. Bring down everything that we don't use. Negative 3y is greater than or equal to 21. Then what? Good. Okay. What do I have to do? Flip the symbol. Right. Now we know if I'm dividing or multiplying by a negative value with an inequality, I flip the symbol. 21 divided by negative 3 is negative 7. So there's my answer. Y is less than or equal to negative 7. Y is less than or equal to negative 7. Okay, so I'm given a number line down here. Here we go. Let's make put negative 7 here, negative 6, negative 5, negative 4. Well, you see it. Then we have a closed dot at negative 7 going to the left. Closed because it's already, yes.
Does it matter when you graph the 6 points on the line?
The ones that I give you, no. I mean, it's the ones on the quizzes and tests, more often than not, I'm going to have the numbers there for you. But as long as you show me a couple points around the dot that you do, that's fine with me, if it's not already pre-labeled for you. I'll be pretty lenient on that. All right, so let's keep it going now. What do I do first? What do I do first?
Subtract 6.
Subtract 6 from both sides. I subtract 6 from both sides. So that's going to get me a negative 18 is greater than or equal to 3x. Mackenzie, finish it off for me.
Then you divide both sides by 3.
Good.
Negative 6 is greater than or equal to x. And then if you switch the x to the other side, if the x is less than or equal to -6.
Very good, and that's my answer. Good. X is less than or equal to -6. Can somebody tell me, why didn't we switch the symbol here? I see a negative. Why didn't we switch the symbol? Nate?
Because you didn't divide by one.
Right, I didn't divide by a negative. I divided by a +3. I didn't divide by a -3, I divided by a +3. So now I divide by +3, that gets me -6. Now, the x is on the wrong side, it's on the right side, I need it on the left side. X is less than or equal to -6. And now I can graph here is -6, and we'll put 0 right there, closed dot on -6 going to the left. Questions about that? Yes, sir.
Do negatives always go away from 0?
Not necessarily. Like if this just so happened, if I flipped the symbol at the very beginning, like if I changed the problem and done it differently, I would have gotten x is greater than or equal to -6, and then it would have gone towards 0. Okay. One more. To solve more complicated inequalities, you may first need to simplify the expressions on one or both sides by using the order of operations, combining like terms, distributive properties, simplify before we evaluate, right? And don't forget, we want to simplify each side of the inequality before solving for the variable. And let's always try to remember to, we're not there yet. Sorry. I almost said get rid of the little guy, but not yet. Solve the inequality and graph the solutions. Oh, this is kind of an interesting one there. What is 2 minus a -10? Throwback to like first day. What's that? What do I have to do with that minus a negative? Yeah, make a big plus sign, make a big positive. 2 plus 10 is 12. So 12 is greater than -4t. And now, to solve this one, I would need to divide by -4. When I divide by -4, yes, Nate? Change the sign. Flip the symbol, less than. I got t on the right side, and now this 12 divided by -4 becomes a -3. Now, again, my variable is on the incorrect side. It's on the right side. I need it on the left side. So I have to actually flip the symbol again. T needs to go on the left, -3 needs to go on the right, and now this less than changes into a greater than. And that's my good answer there. And the reason I want it that way is because now when I go to graph, I can use the graph and say, okay, it's going to point to the right now. Here's 0, -1, -2, -3. We'll put -4 there for good measure. Open circle at -3, going to the right. See, Carson, that's one of the ones where it goes towards 0. Questions on that one? We're just using our properties that we learned at the end of the last chapter, combining them with what we know from the inequalities that we've learned already in this chapter to solve any sort of inequality that we would need to. Okay, what do I do here? What do I do here? Ben? Yeah, distribute the -4. And when we do that, that's going to get us a -8 plus 4x. Everybody watching me there? -8 plus 4. -8 plus 4. Negative times a negative should be a positive 4x. I add the 8 over to the other side. That's going to be 4x is less than or equal to 16. And then I divide by 4 to get x is less than or equal to 4. Questions about that? Now I have a closed, or which one is it? Closed or open on 4? Closed. Going to the left. Again, what does that mean? That means that any number to the left of 4 would be a solution. So like 0 or 3. Any number to the left. So let's plug in 0. Let's see if that would work. 2 minus 0 is 2. -8 times 2 is 4 times 2 is -8. Is -8 less than 8? Yes. That's a true statement that does come out correctly in the end. Okay, let's take a look at the next one. 3 plus 2 quantity x plus 4 greater than 3. Nate, what do I do first?
I'll distribute the property.
Good. How many people, honestly, would have said 5? Uh-oh. I hope nobody's still doing that. Can you add before you distribute? No, you can't do that. My heart hurts every time I see that. It hurts. Don't hurt my heart. 3 plus 2x plus 8 is greater than 3. Okay, now what do we do? We did the distributive property, now what do we do? Go ahead.
Combine like terms.
Combine like terms. I've got a positive 3 and a positive 8 come together to make 11. And now this is an inequality, a nice 2-step inequality that we can solve. You go.
Subtract 11 from both sides.
Subtract 11 here and 11 here, and I see 2x is greater than negative 8. Then what?
You divide negative, or 2 by negative 8.
So x is, now do I flip the symbol? I see a negative.
No,
Why not?
because you're not dividing by 1.
Right, this 2 is positive that I'm dividing by. Right, so it is a negative 4 result on the other side, but you keep the symbol. Because I was just dividing by a positive 2, not a negative 2, by a positive 2. All right, well, make my quick number line here. Here's negative 4. Here's 0. And I've got an open circle on negative 4 because it's not an or equal to. And then it's going to the right. Questions about that? Now, I'll tell you what. Inequality word problems are extremely important. Okay, are extremely important. Why? Because I feel like I use inequalities a lot more than I use equalities when I'm trying to decide, okay, which is the better deal? Which is the better price? Which is the smaller amount that I'm gonna have to pay? What's bigger than? What's less than? When is that threshold gonna be more than or less than? Okay, I need to know those things, for real life. So these are actually real life scenarios here. The inequalities happen a lot more than equalities. To rent a certain vehicle, we got 2 places. This place called Rent a Ride charges $55 per day with unlimited miles. $55 flat fee. Done. The cost of renting a similar vehicle at another place called We Got Wheels is $38 per day plus 20 cents per mile. So this first place just says, okay, if you're gonna rent it for the day, you got $55. Done. That's it. $55. You could drive it 1,000 miles if you really wanted to. It'd be hard to do in a day, but $55. The other place says, okay, we're gonna only charge you $38, but we're gonna charge you a rate of 20 cents per mile. So obviously there's gonna be some amount of mileage. Like if I go 1,000 miles in the We Got Wheels place, obviously I'm gonna pay a lot more money, right? Because it's gonna charge me per mile, where the first place did not charge me per mile. So when is that threshold? When is it gonna be greater than to less than? That's what we're looking at here. For what number of miles is the cost at Rent-A-Ride less than the cost at We Got Wheels? So we wanna know when Rent-A-Ride is gonna be less than the cost at We Got Wheels. I like to try to put it in terms of the problem. I know it kind of looks weird. I'm like abbreviating there. But I like to try to put it in terms of the context of the problem because the last sentence will really tell me what my inequality should look like. For what number of miles is the cost at Rent-A-Ride less than the cost at We Got Wheels? And now I can plug in to solve. You have a question? Okay, so let's just talk through this here. So Rent-A-Ride is $55. Again, there's no variable here. If there's no variable there, it's just $55 flat fee. Liam, eyes open. Thank you. Yep, that's not pushing the car around. I can see what you're sleeping. So $55 flat fee. On the right side, I got We Got Wheels is $38 plus an additional cost per mile. $38 plus an additional 20 cents per mile. So if X is the amount of miles, I know it's 0.2X. And that's the inequality that I can create. Why don't I make this or equal to? Well, I didn't tell you to do it or equal to. I just wanted less than. I didn't want less than or equal to. So let's figure it out. Let's see here. I subtract the 38 to both sides. And that's going to be, looks like 55 minus 38. Oops, out of there. 55 minus 38. Get 17, right? Yeah. 17 is less than 0.2x. And then when I divide by 0.2, 17 divided by 0.2, that's going to get me 85. 85 is less than x. And now, I like to, so I can interpret it correctly, I like to switch that around, and I like to say x is greater than 85. Okay, what did x equal? What was x? If I didn't really define my variable yet. What was x, Carson? It was the amount of miles, right? So we're saying 85 miles. Is it equal to 85 miles? What am I really saying with this statement? What am I truly saying with this statement? See, this is where some of us get caught up. You have to make a statement in the end that uses the inequality in words. Aiden? Okay, but did I want it to be the same price? No, I wanted one to be less than the other. So what do I have to say about the inequality then? Kenzie?
You either say greater than 85 miles or 86 miles or equal to or greater.
Okay, I see what you're saying there. So let's say more than 85 miles. Now, let's be actually even more precise. What do we want to put in front of more than 85 miles? What did we start with? We started with the cost of rent-a-ride is less than the cost that we got wheels. The cost at rent-a-ride is less than the cost at we got wheels for more than 85 miles. It's always good to restate the question within your answer. Have you guys learned that like in English classes? Like when you're answering a question, it's always good to restate the question within your answer. So what was the question? For what number of miles is the cost at rent-a-ride less than the cost of we got wheels? The cost of rent-a-ride is less than the cost of we got wheels for more than 85 miles. Okay, so what does that mean? That means that if I drive 86 miles, then the cost of rent-a-ride is going to be less than the cost of we got wheels. If I drive 80 miles, then this is no longer true, right? And the cost of rent-a-ride is going to be bigger than the cost of rent we got wheels. Okay, so there's that threshold there where one is going to be overbalancing the other. Okay. All right. Okay, that's all we have for today. I believe so. No other slide. No, nothing else on the guided notes. I can go back to this one. All right, so let me end the recording here. So long, everybody at home.